Hello friends, we are going to learn about selection sort today. Selection sort. So what we do in this particular algorithm is, as the name suggests, we are going to select. And what we are going to select? We are going to select minimum element. Okay. So from where we are going to select this minimum element? We are going to select this minimum element from unsorted part of array. Okay. So what do we do in selection sort logically? See, in selection sort, we are going to divide array into two parts logically. Okay, one part will be unsorted and another part will be sorted. And repeatedly, we are going to select minimum element from the unsorted array and we are going to append it to the sorted array. Okay, so in sort, what are we doing? Selection sort algorithm. We are going to select minimum element from the unsorted array and we are going to append that minimum element to the sorted part of array. Now let's understand it through an example. Let's take this example. 21, 1, 32, 42 and this one is 62. Okay. So what is going to happen in first iteration in that? In first iteration, whole array will be unsorted. Okay. So the minimum element will be picked or selected and minimum element will be appended in the sorted array. So do we have a sorted array here? No. So minimum element will be appended here. 1, 21, 32, 42 and 62. So after first iteration, this will be my sorted array and this will be my unsorted array. Now what is going to happen in second iteration? In second iteration, we are going to pick minimum element from this unsorted part of array, which is that for clear understanding, what I am going to do here is that I am going to replace the 62 with 11. Now see, which is the minimum element in this unsorted array? The minimum element is 11. So we are going to select this minimum element and we are going to append this minimum element in the sorted part. Okay, this is my sorted part and I am going to append it here. That is 11. So if I will append 11 here, then 21 will move here. That is, we are going to swap these two numbers in sort. Now 32 and 42 will be as it is. In other terms, you can say that in selection sort, what we are going to do is, in first iteration, we are going to select minimum element and we are going to put in at the 0th index of the array. And in second iteration, we are going to select the minimum element from A1 to AN, okay, and we are going to put it at first index in second iteration. In third iteration, we are going to select minimum element from A2 to N and we are going to put it at A of 2. Okay? So what is going to happen in the third iteration? In the third iteration, minimum of this 3 is going to be picked and what is that? 21. So 21 will be appended in this particular sorted part of array and the rest of the element will be unsorted. Okay, so after third iteration, this part is the sorted part and this part is the unsorted part. Now what we are going to do is we are going to write a code for it. Let's see the code. For I in range 0 to length of a minus 1. Why I am writing length of a minus 1 here? Suppose you have an array of 4 elements and you have placed 3 elements at its right position. So do you need a for loop for first iteration, that is to place the first element at its right position. Answer is no. So we can do the sorting in only 3 iterations. Okay. So for I in range 0 to length of I minus 1, and for each I am going to create a variable called main index. And firstly, I am going to update it with I. Then I am going to write a for loop, and what I am going to do here, in this particular for loop, I am going to find the minimum element from the unsorted array, and not actually the minimum element, I am going to find the index of the minimum element. As finding the index is going to reduce the number of swaps which is going to be performed. For j in range I plus 1 to length of a. Okay. So we are going to compare a of j and a of min index. That is, if a of j is smaller than a of min index, then what we will do? Then in min index, I will update j. Okay. And once this for loop is over, I am going to check if min index is not equal to I, then swap a of I and a of min index. Now let's give it a dry run. 64, 173. No, sorry, let's take another example. 64, 73 and 1. This one is a better example. Okay. So here length of a, that is length of this array, is equal to 3. So how many times this outer loop is going to run? This outer loop will run for 2 times. That is for I equal to 0 and 1. Now let's write it here. This one is I equal to 0. This one is I equal to 1. Now see what will happen when I will be equal to 0. So first of all, a min index variable will be created. This is my min index variable and I will be updated here 0. Now come to this particular for loop. Now see how many times this particular for loop will run for I equal to 0. That is for j in range 0 plus 1 to length of a. That is for j in range 1, 2, 3. That is, it will run for 1 and 2. So j equal to 1 and j equal to 2. Now let's see what will happen when j will be equal to 1. So a of j will be compared with a of min index. That is, a of 1 will be compared with a of 0. What is a of 1? A of 1 is 73. A of 0 is 64. Is 73 smaller than 64? Answer is no. So this particular line will not execute here. Let's see what will happen when I will be equal to 0 and j will be equal to 2. So a of 2, that is 1, will be compared with a of min index. And what is the min index? 0. So 64. Is 1 smaller than 64? Answer is true. So this particular line will execute and j will be updated here. And after that, I equal to, that is, this particular for loop will finish and control will come here. That is, it is going to check, is min index not equal to I? So answer is true. So this, then it is going to swap a of I and a of min index. That is, swap a of 0 and a of 2. So after this, that is I equal to 0 at iteration, 1 will come here, 73 will be here, and 64 will be here. Okay, this is my array after I equal to 1, 73 and 64. Now let's see what will happen when I will be equal to 1. Sorry, this is the array after I equal to 0th iteration. And now we are going to see what will happen when I will be equal to 1. When I will be equal to 1, first of all, a min index variable will be created and value of I will be updated here. That is 1 will be updated. And now let's see how many times this particular for loop is going to execute. For j in range I plus 1 to length of a. And j is, sorry, j will run for I plus 1 to length of a. I plus 1 is 2, length of a is equal to 3. So j will run for only one time, that is j equal to 2. So now what will happen? A of 2 will be compared, that is this particular one, A of 2 will be compared with A of min index. And what is A of min index? Min index is A of 1. So A of 2 is equal to 64. A of min index is equal to 73. Is 64 smaller than 73? Answer is yes. So swapping is no. Min index will be updated, and in min index A of j will be updated, that is, sorry, j will be updated, that is 2 will be updated. Now this particular for loop will finish and control will come to this particular line, that is it is going to change. Is A of min index equal to I is equal to 1, min index equal to 2. Is these two equal? No. So we are going to swap A of I and A of min index, that is A of 1 and A of 2 is going to be swapped. And after this particular for loop, array is going to become 164 and 73. So as you can see, my array is sorted. Okay. Now what I am going to do? I am going to do algorithmic analysis for it. So first of all, what is time complexity here? Time complexity. So time complexity is, see, this outer for loop is going to run for O of n minus 1, and this for loop is also going to run for O of n minus 1. You can say O of n also. Okay. So the time complexity will be the product of these two things, O of n and O of n. So O of n square. What is space complexity? Space complexity. We are going to need only this particular variable. So space complexity is O of 1 here. Now other important thing is number of swaps. As you can see, after, that is for every I, that is you can say for every I am performing a swap if required. So in worst case, we are going to need O of n swaps. Okay. And other thing is stability. Okay. Is selection sort stable? Answer is no. Now let me show why is it so. Suppose this is your array 64, 32, 64, 5 and 1. So after sorting, let's see, we'll leave the sorting part. What is going to happen after first iteration? 1 will be copied here, and this particular 64 will be moved to the last index, and 32, 64 and 5 will be its as its right position. Okay, that is in the unsorted array. As you can see here, this 64 is here, this 64 here is here, that is at the second index, and this is at the fourth index, and in the that is unsorted array, it was here as 0th index. So this particular 64 is before this particular 64 in the unsorted array. But when the array will be sorted, this particular 64 will be before this 64. So is it stable? Answer is no. Okay. So you can give it a thought. Now friends, this is all I have for selection sort, and in next video I am going to bring a lecture on insertion sort. And if you have liked this video, then please like, share and subscribe, and thanks a lot for watching.